Okay, acid deposition, most commonly probably thought of as acid rain. What is that? Well, actually, acid rain is directly related to a few anthropogenic pollutants. For instance, probably most notably the SO3 that I think I mentioned earlier, which is a type of anthropogenic pollutant that is formed or put into the air during burning of fossil fuels. Well, SO3 then can combine with liquid water in the atmosphere, and it can form H2SO4. If you might be familiar with what that is, and H2SO4 is sulfuric acid. So this is basically the origins of this acid rain. And acid rain, when it falls from the sky and interacts with the earth, definitely has, like the slide says, a corrosive effect. Breathing in this acidic water vapor can be harmful to your health. And I think the last thing on here, it talks about how this acidic rain actually can wreak havoc on wildlife and plant life. So if you're familiar or unfamiliar, just here's a kind of a brief look at when we say something's acidic, we're saying that something has a pH that's less than 7. If something isn't acidic at all, what we call neutral, it has a pH of 7. Anything less than a pH of 7 is what we call acidic. Now the pH scale actually is a base 10 scale. And so it seems like there isn't much difference between a pH 7 and a pH 6, but there's a 100-fold difference between a pH 7 and pH 6. So that's kind of how that works. Tomatoes are acidic. They run, looks like it's pointing here to maybe 4.2, a pH of 4.2. Carbonated soft drinks are acidic, that sort of thing. And just to kind of quickly show you what's on the other side of pH 7, then we have what we call basic or alkaline nature of the solutions. So acidic is low pHs. So with that in mind, actually our typical rainwater runs about a pH of 5.6. Now that's water that has no influence of this SO3 interacting with water vapor to form, or liquid water droplets to form sulfuric acid. But check this out. This is a colored, and there's another one coming up. I snagged this from another textbook. But this kind of red region right here is a pH of less than 4.2, when typical pH is about of rain is about 5.6. So that is what we call the most acidic. Okay, and then it's kind of a bullseye effect. Now, the reason these folks here in the Northeast get their rain is so acidic has to do with the fact that they are kind of downwind from, generally speaking, maybe a lot of other industries. Remember, in the Ferrell cell, we're under the influence of the mid-latitude westerlies. And there's a lot of industries in the Northeast. So this is how they kind of come to have this acid rain problem. Notice that, and there's a few other things that we can do, but one way to at least try not to pollute the area where the factories are is to simply make their smokestacks that emit their after they burn fossil fuels, emit their effluent, to make them taller. And as you make them taller, then it kind of at least carries things downwind. But you can kind of see how we've definitely got a concentration of acid rain in the Northeast. So taller smokestacks improve local air quality, not necessarily downwind. Now, one of the things I want to point out on this slide, notice how this milky white sort of, we call it effluent as it's coming from the smokestacks. That milky white isn't necessarily all like, I don't want to say all like particulates and pollution. Quite honestly, one of the things that's produced during combustion is water vapor. And so that some of that most likely is water vapor that's condensing. Just as water vapor would condense in a cloud to liquefy, so also this warm gas, the water vapor in it is also condensing. So I kind of wanted to point that out, that sometimes we look at this and we think, oh, how nasty. And probably rightly so to a certain degree. But we do have some water vapor condensation there. So this is a map from your textbook that shows the pH of acid rain. And so you can kind of see this pH scale where the reds are the worst and the blues are the best. And so let's see, let's find us. Here we are in Iowa. We're kind of a moderate or kind of a light green there. Looks like we're running a pH of maybe 5.1 to 5.2.